Here, we will learn about the method of substitution. Let us consider the general form of the pair of linear equations in two variables x and y, and see how we proceed stepwise in this method. First step is to choose one of the equations, which is convenient to select, and take one variable and express in terms of the other variable. Say, y in terms of x. Second step is to substitute this value of y in the other equation, to get an equation only in one variable, that is, in our case, in terms of x, which can then be solved. Third step uses the value thus obtained in second step, by substituting it in first step, to get the other variable, that is y. In this way we get the solution as values of x and y. Because we have substituted the value of one variable, to express it in terms of other variable throughout the solution steps, we call this algebraic method, the substitution method. Let us understand the application of this method through a few examples. Solve the following pair of equations by substitution method. 7x minus 15y equals 2, and x plus 2y equals 3. From the second equation, x is 3 minus 2y. Putting this value of x in first equation, we get 7 times 3 minus 2y minus 15y equals 2. Simplifying this equation, we get y is 19 by 29. Substituting this value of y in equation 3, we get x is equal to 3 minus 2 times 19 by 29. This simplifies to x equals 49 by 29. We can verify the solution by putting back the values in each of the given pair of equations. Solve of Tub and his daughter's age problem from a previous exercise, by substitution method. Let us recall the algebraic pair of linear equations formed, where of Tub's current age is y years, while his daughter's current age is x years. From second equation, y is 3x plus 6. Substituting this value of y in equation 1, we get 3x plus 6 minus 7x plus 42 equals 0. On simplifying this we get minus 4x equals minus 48. This implies x is 12. Again, substituting this value of x in equation 3, we get y is equal to 3 times 12 plus 6, which is 42. Hence the solution obtained is of Tub's age is 42 years while his daughter's age is 12 years. The solution also satisfies the given pair of equations. Solve the stationery shop example of pencil and drawing sheets by substitution method. Let us recall the algebraic pair of equations formed. From the first equation, x equals 36 minus 4y by 3. Substituting this value of y in equation 2, we get 6 times 36 minus 4y by 3, plus 8 times y equal to 72. This simplifies to 6 times 36 minus 24y by 3 plus 8y equals 72. Again, this will be 72 minus 8y plus 8y equals 72, that is, 72 equals 72. This statement is true for all values of y. However, we do not get a specific value of y as a solution. Therefore, we cannot obtain a specific value of x. This situation has occurred because both the given equations are the same. Therefore, equations 1 and 2 have infinitely many solutions. We cannot find the unique cost of a pencil and a drawing sheet, because there are many common solutions to the given situation. Solve the rods example by substitution method. Let us recall the algebraic pair of equations. From the first equation, x equals 6 minus 3y. Substituting x in equation 2, we get 2 times 6 minus 3y plus 6y minus 30 equals 0. This simplifies to 12 minus 6y plus 6y minus 30 equals 0. This implies minus 18 equals 0. This is a false statement. Hence, the equations do not have a common solution. So the two rods will not cross each other. Please pause the video, rewind and play again to absorb what has been covered in the topic. Let us proceed now.